my name is Kaiya Roberson, and my study looked at the effects of classroom temperature on test scores. I originally wanted to do my study on this because I noticed the temperature of my classrooms fluctuated so much. Some days they were super cold and some days they were super hot. It didn't matter the temperature outside was. The classroom temperature just was always different. This personally affected the way I learn because I get very sleepy whenever a classroom is too hot, and I just cannot focus whenever a classroom is too cold. So I wanted to use my own personal experience to see how this would affect other students and specifically how it affected their test scores. Past research has found that classroom temperature does affect students' learning and test scores, but it looks at students under the age of 18, so elementary, middle, and high school level students. As well, it looks at ventilation rates and other manipulations alongside classroom temperature. Past studies don't really look at how classroom temperature on the day of a test affects students' test scores, but rather just overall how classroom temperature affects students' learning as well. My study looks at ages 18 plus college students, and it has the lesson done in a neutral temperature classroom and the test being taken in a changed temperature classroom to look at specifically how classroom temperature affects test scores. My null hypothesis states that classroom temperature has no effect on college students' test scores. And my experimental hypothesis says that classroom temperature will affect college students' test scores. Specifically, I think that the hot temperature classroom will show lower test scores, and the neutral and cold temperature classroom will have higher test scores. My study is a factorial design because there is one independent variable, which is classroom temperature, with three conditions: hot, neutral, and cold temperature classroom. And the dependent variable is test scores. Each participant will only attend one of the conditions, not all three. The participants were randomly assigned to one of the three conditions. Participants started in the psychology lab in Riggleman Hall, where they were provided two consent forms, one for me to keep and one for them to keep. The participants then were instructed on what the study was about and watched a 6.5-minute long video lesson on basic facts about Canada. After the lesson was complete, the researcher, me, stated that the psychology lab must be used by another student, prompting everyone to relocate. Relocation occurred to move participants from the neutral temperature classroom to the changed temperature classroom, whether that was hot, cold, or neutral temperature. It depended on which condition they were selected for. I then got the participants seated and took my time setting up the PowerPoint, allowing for the participants to feel the effects of the new classroom temperature, along with resting from the walk to the other classroom. Each participant received a test with choices A through D to answer the questions on the board relating to the video previously watched. The participants had an equal amount of time to answer each question. After completion, the participants were debriefed and made aware of any deception used within the study. Deception was used to keep the participants naive to the hypothesis that I was looking at classroom temperature and test scores. Consent forms and data were collected, and then a one-way ANOVA with post-hoc tests were run to determine significance. The materials used for this study was a paper answer sheet with folder and consent form, video lesson from YouTube, an AC unit, and heater to change the temperature of the classroom. On the right, you will see an example of
about this cool country.
The answer sheet that
Canada
was given
is
to
the
them.
second largest country by area in the world, with Russia being the largest. It spans across almost 4,700 miles and 6 time zones, though it only is home to around 1/2 of 1% of the world's total population.
4,700 miles and 6 times
time zones, though it only is home to around 0.5% of the world's total population.
Here are a couple examples of what the questions on the board relating to the previous video looked like for my participants. The first question was, Canada has the longest blank, and they chose A, B, C, or D on their answer sheet. I had 7 participants in the hot condition, 5 participants in the neutral condition, and 8 in the cold condition. I would have preferred to have had at least 10 in each condition. However, it was a struggle to find participants for my study, so I had to work with the numbers that I got. If you look at the highlighted number, that is my p-value of 0.869, which is unfortunately not significant. In order to have significance, your p-value must be 0.05 or less. If you look under mean value, you will see that the average of each conditions tests were pretty similar. They were only about 1 point off. However, if you look at the graph on the right, you will see that the number for hot is lower than cold, and cold is lower than neutral. This aligns with my experimental hypothesis that neutral and cold will have better test scores than the hot temperature. However, I just did not have enough participants to actually find significance in my study. If the study was replicated with more participants, I believe that there would be significance in my study. Some limitations in my study are obviously the number of participants I had. I needed at least 30, 10 per condition. However, I was running a little short of that due to the struggle to find participants to take part in my study. Having more participants helps find significance in a study, so the study would definitely need to be replicated with more participants next time. As well, outside temperature is a limitation because some of the days the temperature outside was hot, and so when I had my hot condition, people were dressed accordingly with shorts and t-shirt on. Whereas one of the times I ran a hot condition, it was cold outside, so people were wearing hoodies and pants and found the classroom hotter than the other time I ran it. And the control over the classroom temperature is another limitation because it is difficult to control the temperature in the classrooms at the University of Charleston. So I had to use a heater for my hot condition and an AC unit for my cold condition. Therefore, I was unable to get an accurate temperature reading of the classroom. I just knew that it was hotter or colder. In conclusion, significance was not found in my study after running tests. More participants are necessary to determine if the results are not significant truly because classroom temperature does not affect test scores or if it is due to something else. More studies also need to be done looking at specifically how classroom temperature affects test scores and not just overall learning, because it is important to have a proper classroom environment for students to succeed. Factors such as outdoor temperature or what people wear must be taken into account when running this study. In the future, the study cannot be used to determine whether or not classroom temperature has effects on students' test scores at this time. Thank you for watching my presentation, and I hope you were able to learn more about how classroom temperature affects students' test scores.